Hello and welcome everyone to this webinar titled OpenTect Machine Learning Developers Q&A. My name is Hardeep Jaglan and I work as a senior geoscientist at DGBS Sciences, the company behind OpenTect. Now the primary objective of this webinar is to help people get up to speed on Python development around OpenTect's machine learning plugin to code their own custom machine learning workflows. So we are going to cover things like using the training data extracted in OpenTect in your own IDE and importing the custom trained ML models back into OpenTect so that they can be easily shared and used by non-Python geoscientists and engineers as well. So today we have our CTO, Arnaud Huck, with us, who is the architect behind our machine learning plugin. And he's going to help us answer these questions. We have already received a few questions in advance, which is what we'll first start with. You are more than welcome to ask more questions through the chat box during this webinar, and Arnaud can later answer those as well. So Arnaud, probably you are going to start by introducing the ML knowledge base, and thereafter we can start with the first question. So over to you now.
Yes, thanks, Hardeep, for this introduction. So, yes, I would like to share with you this webpage, which is within the dgbpy.com website, which is where we gather all the information that is pertinent for using the machine learning plugin inside OpenTect. To start with, you'll find the a direct link for installing OpenTect, for accessing the free datasets we have hosted on Terranibis, the F3 data or the Penobscot data. More importantly, you see a direct link to the Discord community, which is an initiative we have started in order to give our users a quick chat platform where they can discuss the various questions around the machine learning plugin outside a webinar such as this one. So this is it's also partly extending our knowledge base. So users are asking questions on how to do one part or another of the of any machine learning related workflow, and we try to answer these in detail. So it can be joined just by clicking on this link, and that actually then starts a pane like you see here now on my screen, where we have gathered a number of relevant topics, including the announcement of the or the webinars, and also per topic discussion. So you have one discussion channel, for instance, centralized on the odpy Python module, one on the dgbpy module, one on the Seismic-based workflows, one on the well-based workflows. So this is really supposed to be a collaborative platform to discuss how to do any work with the machine learning plugin. You'll find on this knowledge base a number of links to the previous videos, the previous webinars we have hosted, and that will, of course, necessarily be expanded with time with more adequate documentation. So you have a direct link to the machine learning user documentation in the OpenTect website. And we have a dedicated documentation per plugin. We are at the moment still writing an expanded version of the documentation for the odpy Python module we wrote as part of the machine learning plugin, and that will soon be complemented by a similar documentation for the dgbpy plugin. Then eventually you have a number of workflows which are presented here at the base, and code examples that you can find and download on GitHub. This is, I would say, if you are starting with the plugin, really the one place to go to dive into these documents, see what the software can do and how you can possibly apply it to your own workflow. Okay, it's complemented by a number of other parts of the web page. When showing the various videos as webinars, we have an FAQ that you can join, especially on how to join the Discord community, how to get questions, and so on. So that would be to present really the knowledge based of the machine learning plugin. Are there already questions so far?
Yeah, we do have a few questions already. So thanks, first of all, for introducing this one-stop resource for machine learning knowledge base. The first question that we have is, how can I add my own trained models to the OpendTect database? If you could please elaborate.
So if you have a model that you have trained yourself in Python, there's really only one place to go. For this purpose, I'll be opening the OpendTect window. In the survey menu, just like for any data import in OpendTect, you'll get all the various options per data type, ending with the one option which is part of the machine learning plugin to import pre-trained models, and that gives you such a window. So this is a kind of a standard window where you can select any file. So in my case, let me just expand slightly the window. I've selected somewhere on my local drive a file path, the file path to an H5 file, which is a model that was trained with the Keras platform. And the import window will actually run a number of Python tools to digest this file and try to extract information from it. Some of the information it can extract is, for instance, to look at the model geometry. So it's trying to pick up if it was based on a 2D convolutional model or a 3D convolutional model. It's normally supposed to be able to recognize the image shape for both the input and the output. And if you're running a classification, for instance, it can automatically extract the number of labels that you have trained your data on. It also recognizes the number of input attributes. So that means that from this Keras model, which was trained in Keras, well, I still don't have a relevant name for the input attribute, but it knows that it is based on a single attribute. So if I know that it is seismic data, I can pre-fill the name of the input seismic attribute, just like I can pre-fill in this form the name of the, so this is a supervised classification workflow. The name of the supervised classes can be filled in to provide labels for this trained model. There's one piece of information which is basically almost never going to be stored alongside the trained models, that is the scale information. Scale information really is very important to get and to set in the right way if you are planning to predict this trained model on a project from which it was not trained. So if you are, for instance, if you have trained this model on, let's say, one block somewhere in the North Sea, and you're trying to apply it on a seismic survey somewhere else in the North Sea, if you want the prediction to really work nicely with the scales of the seismic data, you have to provide information on the average and standard deviation. So typically you would do that. You could do it in OpendTect. Again, providing that you have access to the data, you can pop up a histogram of your seismic data and use the reported mean and standard deviation to report here in the form. So I don't necessarily need to be completely accurate. I can, because it's seismic, and can simply set a zero mean, but at least I'll give a chance for this trained model to know on which scale it was trained on. And that's basically how far you can go in the current version of the machine learning plugin. The import will will reference that trained model in your current project and make it available for you for either running a prediction or also for running a transfer training or resume the training of that model with more data. Now, we also want to give you the possibility to share your models across the organization, across the team, but also to get access to predefined, pre-trained models. If you look at the current control center at the bottom of the tree of items that you have here, you get a number of pre-trained models. In version 6.6.4 of OpendTect, there's only one. In the incoming version 6.6.5, there'll be several additional pre-trained models, where these models also need somehow to be accessed and retrieved before they are available in your current project. In order to do this in a nice and collaborative way, we actually want to expand the scope of this import tool to support easy sharing of the trained models through the team. So we've made a very small presentation on how that would look like in future releases. So first of all, what we want to do is basically to remove the pre-trained model items from the main tree here to make it a top-level item directly in the machine learning control center. And that complements basically the icons you have in the toolbar here at the top. So the pre-trained models will have their dedicated subtree directly in the machine learning control center. And some of these models, if not all, will not be shipped directly with the software because they can be quite large. They can be hundreds of megabytes large. That would make the size of the machine learning software too big, which is why that in this tree, you'll get a download button for all the pre-trained models which are not installed yet on your machine, but which can be downloaded from web resources. These downloads would be then either from a cloud storage or from an on-premise network location. For each model to be downloaded, then you'll have an access to the pre-trained model information, and will give you here an overview of where you can set the pre-trained model disk location. So if you have, that basically means that you can point to one location on the network where the downloaded models have to be saved. So if I start with the pre-trained model information, purpose is to show a user interface like this, which is much more extensive than the one we have so far, which will show not only a very short model name, but also the purpose of why this model was trained, on which kind of input it was trained, what output it is going to create if you use that model to run a prediction, and few other pieces of information like the image on which it was trained, and the actual file on any actual path on the network of the file, with a relevant summary of how this model was actually trained, and that should give you a quite precise idea of how to use it eventually. So the second button here to provide the pre-trained model locations will be starting with, by default, 2 locations which are set by the software installation, and the additional locations can be set by the user in this dialog. So that will become the default download location for any model which is downloaded through this machine learning control center. And again, this this location can be just on your local drive, but it would ideally be a shared mounted disk location, either on a Windows share or Linux share. The further improvements we want to bring in is really the possibility when you import a model to provide all the model information that I've displayed 2 slides before. Okay, so that means that there'll be more collaboration through the team available, because when an interpreter is done training a model, I should pre-fill that model information after the model is trained and QC'd, and before it gets shared with the team. Yes, and to really finish with this question, the purpose is to download models which are either public models. So for this, a normal download link would be directly available. But if you use if you also want to share these items inside the company, then you can also will also want to expand this import tool by giving you the access to get trained models from a company-wide cloud location. So an Azure bucket or an AWS network storage, which would be private within your company. Any more questions on?
Yeah, sure. Thanks.
Yes.
Thanks for this quite detailed reply, by the way. Yeah, the second question is now about the training example data created in OpendTect. How can one use that outside in their own Python code or environment?
So to locate data which has been created inside the machine learning plugin, you need to use the model managers. The model managers you can reach in 2 ways. Ideally, I would always recommend you to do it through the control center by starting the corresponding workflow dialog. It's going to start in a moment. And inside these windows, you find always on a selection field to provide input data or to select output data, you always find a tiny manager icon. So this manager icon will show you the list of all the here example datasets which have been extracted in this project. And they also show you a tiny summary of what they contain. So you see the dataset name, which is the target for the prediction. You see what kind of workflow it is. So this is a classification, a binary classification, and you get the full file name of that example data and its location. It's telling you basically where on disk this data is located. Now, if you want to then get access to this data set, not in OpenTect, so in OpenTect, all you would have to do is to select this file, either in the extract tab or in the train tab, you would also just select that file. If you're in Python, you'll be making use of the dgbpy module. So in order to start working in Python, I actually started the software IDE in OpenTect from this dedicated toolbar. So if you saw in version 6.6.4 of OpenTect, we added a dedicated toolbar here, which is especially meant for Python usage. So it has one icon to show the current Python settings that are to be used. So internal means that I'm using the Python software which is shipped with the OpenTect installation. I can, of course, test this. I can open a command prompt, which I did just prior to this meeting, and I can launch the IDE, or I can launch my Spider Python IDE just on the command line with this command prompt window. So once the IDE is started, I can make use of the two I can make use of the two modules, odpy and dgbpy, which come with the OpendTect software installation. odpy is part of the OpendTect as such. dgbpy is part of the machine learning plugin. And basically, they are directly usable out of the box. Now, these modules contain a number of Python packages, which are not, some of them are ready for internal usage by the machine learning plugin. Some others are more focused on also being used externally. And I would say as a user of the machine learning plugin, you'll be mostly using either the MLIO package or the MLApply package. The MLIO, which stands for Machine Learning Input-Output, concentrates all the functionality which is needed in order to read data which has been created by the machine learning plugin. So providing that I create a file name string, so that's the full path to one of the file which was created by the data extraction in the machine learning workflow. And you have to mind that on Windows, you have to duplicate these symbols to get the file path right. So providing that we have a file path, you can read the data behind this file in Python very easily with just one command, one function of MLIO, which is the get training data function, which basically takes care of reading the entire file and preloading all of its content in memory. What it creates, as we can see with the variable explorer, if I double click on this one, is that we don't get directly just one single object. We get a tiny dictionary with 3 items in it. One item is again a dictionary. It's kind of a header dictionary, and it contains 2 arrays. So if we look at the info dictionary to start with, that shows us a summary of what we could have seen as well in OpenTect from the example manager. So it shows you very similar information, and I'm just going to select the very same file, left and right. So it shows us that we are dealing with a classification, supervised seismic classification. We have 5 classes to be predicted, labeled, well, numbered 1 to 5 in our case. And we are looking at an image size, which is actually a 2D image of 128 by 256 pixels. And there is, well, more information. I won't go too much in the detail, but it's to get a tiny piece of information on the content of the file. More important is really to get the 2 arrays of data which were extracted by the machine learning plugin. And these 2 arrays come directly in a fully usable form directly as NumPy objects. So if we want to actually make them available as NumPy objects, we can unpack these 2 arrays from the dictionary using the relevant keys, the same ones as being as we see in the variable explorer. And these are the 2 NumPy arrays that we can use for training any model. So one is an XTrain array, which contains, as you can see from the size box, it contains 70 images, which have 1 attribute, and that 1 attribute has a size of 1 by 128 to 56 pixels. Y-train data is about the same number of images, same size, and that contains the label, well, 0 to 4 in my case, for this classification to be done. And as such, there is not much more to do than running this one single command. Now, if you're more looking into running an actual prediction, having just 2 arrays, XTrain, Y-train, won't be enough to start with, because when running a training, we also nearly always need to split the data between a training dataset and a validation dataset. For this kind of slightly more specialized usage, the mlapply package has a specific functionality to prepare the data prior to a training. One of these, I would say the most important prior to a training, is the function getScaleData. If I run this function now, we'll see that we get again a dictionary, but this time the dictionary has 5 elements in it. So instead of getting just 2 arrays, X train, Y train, we get 4 arrays, 2 X arrays, 1 for training, 1 for validation, and the same pair for the Y data, 1 for training, 1 for validation. So out of the 70 images, we got 56 images for training, 14 for validation, which corresponds to the split of 20%. And that split is done randomly across all the images contained in the file. Okay, so that is really in a nutshell how to access the data which is in an example file. If the data you are trying to access, however, is a model which was already predicted in OpendTect, then we'll be using slightly different functions of dgbpy mlio. For that purpose, if we have the full path to a trained model file trained by OpendTect, then we can call the mlio getModel function. So let me just run this. And the function doesn't return only a model, it always returns a tuple with the model info first, sorry, the model object first and the info object secondly. And you can see that the info object is very much similar to the one we would have for extraction data with a few additional keys. So for instance, it will tell us what platform this model is about. So this model was trained on the Keras platform. The model as such is a direct, it comes directly as an object of the platform on which it was trained. So if the model was a trained Keras model, we are getting a Keras model instance. If that was a trained Scikit-learn model, we would get a native Scikit-learn model object. So all the functionality that you'll find in these two packages, mlio and mlapply of dgbpy, they are all platform independent and they are workflow independent, which means that if you can use the same functionality, get training data, get scale training data, and get model for any workflow that you see in the machine learning control center. It doesn't matter if you're dealing with wells only, seismic data and seismic and wells. It doesn't matter if you're doing a bodies workflow, a seismic image segmentation or regression. It's always using the same API for all platforms, for all workflows, which should make it very easy to use for you.
Yeah, indeed. Thanks, Arnaud. Seems like using these couple of modules makes it very straightforward to get trained example data or trained machine learning models from OpendTect to our own Python environment or Python code. Now, we have a question from one of the attendees, Andres Vargas. He's asking, what are the minimum requirements in terms of hardware to run the machine learning plugin?
So the minimum requirements, in terms of hardware, you can see that we have didn't prepare that one, but we have a dedicated set of system requirements which can be found on our website. be able to find it quite quickly.
Probably in FAQs.
But in a nutshell, it would be we recommend to have at least 32 GB RAM, which is twice the amount that we recommend for OpendTect. And of course, you need a GPU. And I would say, well, it depends which platform you plan to utilize. If you are using the Scikit-learn platform, Scikit-learn doesn't make use of the GPU. So for that platform, having a good CPU is still more than good enough. But if you're running the machine learning platform with the TensorFlow Keras platform, then you'll need then you'll need a large GPU with especially a large amount of RAM. The large GPUs comes with a large number of CUDA cores, which plays a role in terms of performance. But we've seen that the amount of RAM, dedicated RAM on the GPU, actually allows you to provide larger images as input for the training if you are in the Scikit-learn workflow, sorry, in a Keras workflow.
I know apparently on our ML knowledge base, there is already a link to the, I think you might have to refresh the page. And if you refresh the web page, probably there is,
yes. Machine learning system requirements. I'll go for Windows. And you can see that we have really a dedicated section for machine learning.
Perfect.
And well, we do reference 3 cards, but that's just it's an example.
Very well.
There are actually newer GPUs out there now, which run better.
Yeah. All right. So another question on the coding side is, how can I write my own TensorFlow Keras model inside OpenTect environment and make it available in the ML plugin UI? So yes. I don't want to use my own code, but completely write within the OpenTect environment.
Well, you still will have partially to use to provide the model architecture. So in an example such as this one, this is a file where I have pure Keras code written completely. There is no mention of dgbpy whatsoever in this part. So if you have already a fully written Keras architecture, you need to make it available through OpenTect. So OpenTect, we need to first of all find the Python script where this model architecture is written. And secondly, we'll have to make a tiny adaptation to make it understandable by the machine learning plugin. So to start with, how to ensure that your model architecture is actually going to be found by OpenTect. That is partly part of the Python settings. So if you go back to the Python settings dialog, which is this following, you see that you have one line here, which is custom module path. That allows you to set the location to one or several folders on your system where you have your own Python code written. And OpenTect, well, especially the machine learning plugin, will look inside that folder location for potential packages which contain model architectures. Now, because you may have a very large number of scripts written in your own folder, we adopted a kind of a syntax constraint that will only look at the files which start with mlmodel_. So if you have a file in that folder which starts with mlmodel_, that means that the machine learning plugin when it is looking for specific machine learning architectures, it will look for these for the architectures which are present in these files. Okay. Now, how do you go then? We have set the location of this file. We have specified that this file needs to start with this given prefix mlmodel underscore. Now, what about the content? The content was previously something like this, pure Keras code, and needs to be turned into something which is understandable by OpendTect. In order to make it understandable, you'll have to look at a specific documentation we've wrote, which is called Develop Your Own Models. If you look at this documentation, the second chapter is presenting the Keras user model class that we've wrote inside dgbpy. So inside dgbpy, there is one package called Keras classes, which defines the user model class. And this is the one class to use. So that means that the main difference, if we look at the code between this code, which is just a loose function, and code which is ready for being used in the machine learning plugin, is that the function is actually embedded in the implementation of a user model class. So as a user, all we have to do is copy that one line that you see in the documentation to take care of importing everything that you need to that is going to be used inside the file. So we need to import all these data types in the file, and we need to add this header which implements our model and makes it available through the machine learning plugin. So in terms of implementation, the user model will be is based on a UI name. So the UI name is what will eventually be displayed here in the user interface of OpendTect. User description, UI description is more for you to have to present a description of that model to make it slightly more understandable, especially if you share this code across the team. Could be worth having a slightly longer description. And more importantly, you have to provide the characteristics of this model. So few things that OpendTect will need to know, that the machine learning plugin will need to know. It will need to know if this model architecture is applicable to a given workflow which is available in the control center. So some of these workflows run supervised classifications, segmentation, some of them run regressions. So as such, you need to provide the prediction type which applies to this architecture. So in this case, I know that this architecture is for a supervised classification. The output type is pixel, which means that for any input, the model is always predicting one single scalar output. So we are not looking at an image-to-image prediction, but we're more looking at something like which is a seismic bodies classification. But it could also be a lithology classification. The difference might be between the dimension type. With the dimension type, you specify if this model architecture is applicable to 1D data, 2D data, 3D data. Maybe you wrote the model architecture in a way that it actually supports all possible dimensions, 1D, 2D, and 3D. So these enums you find back in dgbpy Keras classes at the start of the user model base class, and that's where you can you'll find all the possible values for every enum. So data prediction so far is either continuous data, so it's a regression, supervised regression, or it's classification. Segmentation is a word we reserved for future unsupervised workflows. And the output type so far is either pixel or image to image. Dimension type is 1D only, 2D only, 3D only, or 1D, 2D, and 3D. Okay. And that explains basically that so far this model doesn't appear in my user interface of this seismic image transformation. Okay, because this model, I'm not running a classification. I don't have an output pixel type, but I'm 3D. So if I would be going to the relevant workflow, so to the seismic bodies workflow, and I go to the train tab, of course I need to select some input. And as soon as the user interface is uploaded, this model should appear alongside the model architecture provided with the OpendTect software. And as such, this is the only thing you'll have to take care of. You will not need to write any code which is about digesting the data, reading the data from a data store, writing to the output model to the data store or such. Everything is going to be done and run internally by the machine learning plugin in such a way that the only thing you have to focus for you as a researcher is to fine-tune the model architecture.
So Arnaud, if I understand correctly, the actual architecture can simply be written inside this make model function. Inside
that file, yes, and the architecture resides only in these few lines.
Right,
okay. You can see on my screen now that in the OpendTect user interface, next to the model architecture, which is pre-shipped with the machine learning plugin, we have access to this model file, which is on my screen.
Right, and only one model can be used in one file, or can it be work with multiple models?
You can define as many models as you want. So if you want to define more models, you would basically duplicate that block. As such, you basically have to create one model class for each model that you want. So let's say that was a 3D model architecture. If I want to define a 2D model architecture, I can switch the dimension to 2D, and of course we'll have to adapt the model architecture and switch from 2D convolutional layers, from 3D convolutional layers to 2D, changing, of course, all the parameters that need to be changed in order to make it applicable to 2D.
Right, perfect. That's quite straightforward then.
And there's not much more to do.
Yeah, right. Right, thank you. We actually have one more question from one of the attendees, Sergey Benkovich. He's asking if I want to concat different attributes with the original Seismic as additional channels and pass it to the machine learning model. What are the best ways or options for efficient data preparation?
So for data preparation, what you would see in the literature when it comes to providing more than one attribute in the more than one attribute as input for a training, that very often people use a one attribute which is encoding the red channel, one for the green channel, one for the blue channel. So if you want to replicate such a workflow, one thing which could be done could be to apply a spectral decomposition on your seismic data, because this spectral decomposition will naturally output different frequencies, which then can be input into such a workflow. So let me just go to the data selection. Okay, so I'm just selecting the labels, but the question is not so much on the labels, but more on the seismic input to train on. So when you select the seismic input, which is going to be extracted for prior to the training, you can, and it's really completely up to the user. You can select a single seismic volume to train on, or you can select if you have several angle stacks, near stack, mid stack, far angle stack. Normally you would not need to do any data preparation because it is coming directly from the processing company without much required change. And as I said, if you did run a spectral decomposition, you may have, I'm not sure I have here, but you may have some spectral decomposition channels, with frequencies, and then you can select a number of stored frequencies of the spectral decomposition dataset as input for the training.
Right.
All the other data preparation techniques still apply, but there are, which is to filter the seismic data, to ensure that to potentially do frequency balancing, amplitude balancing. That is all up to the user to decide to do these pre-processing steps or not. One of the advantages I think we have with the more modern convolutional neural networks is that they are supposed to provide reasonable results, even if you do not do a perfect data preparation. So even if you are training on angle stacks and the angle stacks are not perfectly aligned, normally a convolutional model should be able to still give you a reliable training from it. So the hope to go for model architectures such as what you see available in TensorFlow is actually to skip completely and as much as possible the data preparation and give your data in the most raw form that you have available.
I think Arnaud, yeah, that's what Sergey is actually asking. That of course you have your original seismic, but if you want to use additional attribute volumes like far stacks and impedance volumes, we could just use them in this list. Select them in this list, and they will essentially act as channels.
Yes, they will.
In the TensorFlow terminology.
They will.
Yeah, I think that's what he's asking. Yeah, perfect. Thanks. Okay, so next question is probably more generic. Yeah, I heard you are working on support for Pytorch. What is the status of that development?
We have written basically a translator to allow us to do all the work which we are currently doing using the Scikit-learn platform and the Keras TensorFlow platform in Pytorch code. And that is still being tested at the moment, merged with the current production release. And basically, as soon as we are done with this test, we'll be able to release that to you. The goal is to have it done, to conclude all our internal testing and release it before the end of the year.
Yeah, perfect. Thanks. Yeah, of course, you have shown the ML knowledge base in the beginning of this webinar. Are there any other resources or places where one can ask questions or provide comments or suggestions?
Yeah, the main, and I would say the only channel we really want to put forward is the Discord community. So we really would like you to come on this Discord community and ask the questions because, well, I don't know, maybe Ian knows how many users we have currently on this channel, maybe 100 or 200.
I think around 300.
Users, 300. So that will definitely be the place where you can hope to get questions answers. It doesn't have to be exclusively on OpenTect usage. If you have general question on how to do something with machine learning, you'll most certainly find someone to help you.
Nice.
Yeah. I know in the beginning you showed something about odpy and dgbpy. Maybe you can show where a developer can find these modules.
Yes, so these two modules are shipped with the OpenTect installation. So as such, OpenTect will always automatically find them easily. If you install on Windows OpenTect at a standard location, like on Windows, it's in C program files OpenTect, and then the version number. You'll have in the bin folder a subdirectory Python with all the plugins which are installed through the OpenTect installer. So that's where you'll find the odpy module is coming with the OpenTect installation. The dgbpy module is installed by the machine learning plugin. And you actually have a third one, wmpy, which is shipped with the plugins, the free plugins to OpenTect, which are written by Wayne Mogg, an independent software developer. So everything which is installed through the installer, which is Python related, gets actually down into this folder, which means that once you know where it is in Spider, you can browse to your file. However, if you start Spider from inside OpenTect, you won't need to provide this path to Spider. It will automatically find it. Yes, it is only in the case where you're starting your Anaconda distribution, which is separate from OpenTect, that you may need to provide the path to this folder. Okay.
Yeah. All right. Another generic question at the end of this webinar, Arnaud, is what if someone has a model that they want to make publicly available, or if they want to coordinate with you on a webinar and so on?
Yes.
How could they proceed?
Yes. So to start with, if anyone has a machine learning workflow that he wants to share, we would be more than happy to host a webinar where such a workflow can be presented by one of our users. So just let us know, and we can very easily arrange to host and announce such a webinar at request. If the question is more about how to contribute to and provide a fully trained model, well, since we are still developing the import phase at the moment, it would be necessary to send us the model so we can first of all host it on our AWS cloud storage, so it can be downloaded from there, and then made available through the software. So we have to write. There's a bit of IT that needs to be done, but it's quite easy to do. It will be much more easy to do once we are fully done with the current rework of the import window. If the question is more how to be set up in order to share trained models in a more private manner inside an organization, then you can still contact us and we can help you to basically set up your infrastructure in such a way that you can efficiently share private models within your company. That again will rely on the new pre-trained model import window to be fully finished, but it will be available shortly.
All right. I think that was about all the questions that we had received. So thanks a lot, Arnaud, for this truly informative and practical session on machine learning development around OpendTect. And thanks everyone for your attendance and attention. Please feel free to ask any questions or comments you might have on today's webinar via the chat box, or you could also click on the raise hand button if you would like to ask a question verbally. Please feel free. Let's see if we are getting any more questions in the chat box or otherwise.
Yeah, we got a question from Sergey again. Maybe I missed it, but are there examples for unsupervised?
You didn't miss it. At the moment, we don't have any workflow which runs unsupervised data extraction and training. So it's certainly something which is still missing. Well, you can run unsupervised segmentations along horizons using the traditional neural network module, which is still accessible through the Machine Learning Control Center. But eventually, we want to migrate all these tools to the relevant parts of the current machine learning workflow. Now, as such, you can still use the current data extraction to get all the data that you need for running an unsupervised segmentation extracted. So that means that if we do the data extraction, let's say we are looking at doing an unsupervised lithology classification, just get we can still use this user interface to extract all the data which is needed for the unsupervised segmentation. And that means that these logs will then be extracted, and it's only that the target log is going to be ignored. So that would be, that is at least a way which is implemented, which is working to get all the data that you need extracted for an unsupervised workflow. And I've showed you in the webinar how you can then read this data in Python in order to get the required data. But what is still not supported, that will be the training part. So I would say for the unsupervised workflow, the data extraction is partly covered because it can be done with the current tools, but it's really the training and the application that we are missing, and that we'll need to add in a near future.
Arnaud here, I would like to add that although we don't have a deep learning algorithm as such for unsupervised segmentation or clustering, but in the Seismic tab, you already have horizon-based seismic fishes, which is essentially UEQ technique, which is very similar to the k-means clustering.
Yes. So this one is basically based on the multi-layer perceptron. It's directly available already. Just not for logs. We'd like to have it for logs as well, but it's not there.
Absolutely. All right. We have a general question also from Oluskun Akinmuda. What's the first step towards learning machine learning for beginners? If you have anything to add to that.
That's much more than what was said already. The webinars are always a good way to start with, and I would say if you're a really beginner, it would be worth looking at the two theory webinars presenting what is machine learning, where does it apply, and what are the principles behind it. That's always a good place to start. And eventually, once you're done with the with the introduction, you can go on with the more applied kind of webinar to start with.
Yeah, very well. I think that's the right place to start, indeed.
And there are, of course, just lots of sources available online if you really want to go into the basics of machine learning. I know there's a great course on Coursera on machine learning that just gives a great introduction to different kinds of machine learning, supervised and unsupervised. It really explains what the difference is between the two, when to use what kind of methodology.
Yeah, indeed. Looks like we don't have any more questions. All right, looking at the clock, then it's time to close the webinar. In case you come up with any more questions or comments, you can contact us via support@dgbs.com or any of the channels mentioned in the Discord tool. Again, thanks very much, everyone, for attending today, and hope to see you back in our coming webinar sessions, and perhaps also on this OpendTect Machine Learning Discord channel. Good day, everyone. Bye-bye.
Thank you. Bye-bye.